Alright, hey guys, this video is going to be about improper fractions and how we change them to be a mixed number. First of all, if I say the word improper fractions, you should have a picture in your mind of what an improper fraction is. If you are like, I don't know, that's okay, but just as a reminder, an improper fraction would be something like 11/5, where you have a numerator that's bigger than the denominator, meaning an improper fraction, it's kind of like if you had, I think of improper as being like money. Like if you were going to go to the grocery store and something was $1.25, I would pay them with a $1 bill and then a quarter. But an improper fraction would be like if you gave, instead, you gave 5 quarters, and that would be 25 plus 25 plus 25 plus 25, and we'd get $1.25. But it's kind of like we don't actually speak that way. I would never hand somebody and say, oh, you owe me 5 quarters. I would say, you owe me $1.25. So an improper fraction is not necessarily wrong. It's just that we would like to ideally change it into a mixed number. So as a review, if I have 4/3, let me draw this picture. Again, I look at that and I know it's improper because the numerator is bigger than the denominator. And I'm picturing I have 4/3, meaning I have a piece of pizza and it's cut into thirds, and I have 4 of them colored in. Well, look, there's 1, 2, there's 3/3, but I have to keep going because I actually have 4/3. If I'm looking at 4/3, I realize that instead of saying 4/3, I could just say that I have 1 whole pizza and I have 1/3 left over. I'm hoping that you realize that 3/3 is the same as 1 whole, and that what's left over right here is this 1/3, okay? So we could try 13/5. Like if we look at this picture, here is a visual of 13/5. Each pizza is cut into 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's showing 13/5. But you would never call a pizza place and be like, hey, yeah, can I have 13/5 of a pizza? You wouldn't say that. Okay, you would say, can I have 2 whole pizzas and, so there's 1 whole, another whole, and 3/5 of something else. So the actual mixed number for this is, this looks like 2 whole pizzas, and then 3/5 would be left over, okay? In improper fraction, if you need to change it, you can, like if I had 13/5, you can draw it if you, like that's a strategy. I think it's easier instead to think about it. Instead of like drawing out fifths in every single pizza, I think you should pull out as many holes as you can. So if I think of 13/5, if I'm in my head thinking like, oh, this pizza's cut into 5 pieces, how many fifths do I need to make a whole pizza? So what I'm going to do is I just draw pizza and I'm like, all right, there's 1 5/5, so there's 1 whole pizza. There's another 5/5, so there's another whole pizza. And right now, I have 10/5 total taken out, and I'm trying to get to 13/5. So I need to draw another pizza, but I can't take out 5/5 of this because that would be 15/5. If I have 10/5 taken out and I need to get to 13, I know that in this pizza, I only need 3/5 pizza. Then that shows that I've taken out 13/5 because 5, 10, 11, 12, 13. And then at the end, if I were going to make them into a mixed number, I have 2 whole pizzas and I have 3/5 of another one left over. Okay? Same thing again if I have 7/3. I'm picturing pizza, and I know that it's cut into thirds, but I don't want to actually have to draw that every single time because that can get kind of annoying. I'm just imagining how many thirds I can pull out because I know 3/3 is 1 whole. How many thirds can I pull out to get to 7/3? So if I pull out 1 3/3, that's 1 whole pizza. And I can pull out another 3/3 because that's another whole pizza. And so far I have 6/3. I'm trying to get to 7. Well, I know that I need 1 more third to get to 7/3. In total, 7/3 is 2 whole pizzas with 1/3 left over. If you're ever unsure, you could draw a picture to check. There's 3, 1, 2. There's my 1 3/3. There's 6/3. And here's my 1/3 check left over. And that is 1, 2, 3, 4, 5, 6, 7/3, which is 2 and 1/3. Okay? Let's do another one. 15/4. If I have 15/4, I'm picturing that I need to pull out as many 4/4 as I can. I can pull out 1 4/4. I can pull out another 4/4. That's 8/4. Pull another one. That's 12/4. All right, let's see. If I pull out another one now, that's 16/4, and that's too many. I only need to get to 15/4. So I know that I have 3/4 left over because 4 plus 4 is 8, plus 4 is 12, 13, 14, 15 fourths, okay? If I'm looking at this, I know that 4 fourths is 1 whole, so I have 1, 2, 3 whole pizzas, and then 3 fourths of another pizza, okay? As a reminder, there is a way, remember we talked about how there's obviously there's a trick way or a trick that will get you the answer, but if you don't actually understand it, then you're not actually learning anything about fractions. So on a test that says to show your work, this way is a great way to show that you understand how to change 15 fourths into an improper fraction. If you are trying to do this kind of quickly, instead what you could do is if you have 15 fourths, you have to think of how many times 4 can go into 15. Well, 4 times 3 is 12, right? And then you have to think of how many left over to get to 15. That's 12, 13, 14, 15. That's 3 left over, and it's still cut into fourths. And the reason that works is because I'm pulling out 4 fourths, so I'm thinking of how many full groups of 4 fourths I can pull out to get to 15. I can pull out 3 groups, because 15 divided by 4 is 3, and then I get 12, and then I have 3 left over, and I'm like, oh, that's my remainder. But I know then that if I ever get a remainder, you can make it into a fraction. I know that I pulled out 3 whole things. I have 3 left over out of 4, and I have 3 3/4. If I added 1 more fourth, I would have 4 whole pizzas. All right, let's check another one. 13/6. If I have 13/6, I'm thinking in my brain, how many 6/6 can I pull out to get to 13/6? There's 1 6/6. There's 2, that's 12, so I know I need 1 more to get to 13, and that is 1 whole pizza, 2 whole pizzas, and 1/6 of another one. Or I could think of it as division, because I know that this fraction line actually is a dividing sign, and I could do 13, whoops, what's wrong with it? 13 divided by 6. And in my brain, 6 times what gets me really close to 13? That's 2. And then I have 1 left over. Whoops, and I have it in my thing. I have 1 left over. And I know that I have 2 holes. Remainder is 1 left over out of 6 total pieces. 2 and 1 6, 2 and 1 6. Both of these are different strategies. This is the trick algorithm way, where you could do this, but if you are on a test or you're ever trying to prove or explain why you're doing it, this is not helpful. This way is how you prove to me that you actually understand. Now we're going to do 25/5, okay? I'm thinking, some of you might be thinking, oh, it's 5, which it is because 25 divided by 5 is 5. But if I said you need to prove it, then you would have to show me that you're pulling out 5/5, because if it's cut into fifths, I need 5/5 to make a whole. So there's 1 full pizza, that's 5. Another full pizza, that's 10/5. That's 15/5. That's 20/5. And that's 25/5. So I have 1, 2, 3, 4, 5 whole pizzas in 25/5. Okay? This next page, I want you to, wait, actually, no, I'm going to skip ahead. I'm going to write maybe 2 more on the board that I think that I want you to kind of do, okay? If I had, let's do 14/5, and let's do 9/2. Pause it, and then I want you to make it into a mixed number, and then press play when you're ready. All right, 14/5. I know that I'm pulling out 5/5. There's 1 5/5, that's 5. There's 10/5. Why do I keep doing that? 10/5. There's, oh, I can't do this because that's 15/5, and I went too far. I only need 14. So if I'm at 10 and I want to get to 14, I need 4 more fifths. So I'm seeing 1 whole pizza, 2 whole pizzas, and 4/5 of another one. Okay? Then I'm looking, or I could think of division. 14 divided by 5. 5 goes into 14 2 times, that's 10. I have 4 left over, so I know that I have 2 holes. I have 4 fifths left over, and that matches. Last one is 9/2. Again, I'm thinking how many halves, basically, do I have to pull together? There's 2. 4, oh geez, I'm counting and writing. There's 4, there's 6, there's 8, and I can't do this because that would be 10, and I only need 9. So if I'm at 8, I only need 1 more, and then I can check. 1, 2, 3, 4 holes and a half, or I could do my division, 9 divided by 2. 2 goes into 9, 2 times 4 gets me to 8. I have 1 left over, and I have 4 1/2 as my answer. If you are like want to practice some, you could just make up any improper fractions where the numerator is bigger than the denominator and then practice that way. Okay? All right. Thank you. Hopefully you have a better understanding of improper fractions.